Jai to all. Today I am here to present the video lecture on subject digital signal processing, and this is the lecture 4 of the series, circular convolution and linear convolution. So here in this particular lecture we will see the what do you mean by circular convolution, what is linear convolution, what is the difference between these two, and we will see the various methods to find out the value of circular convolution and linear convolution if the sequences are given to us. And we will also see in case of linear convolution that what happened when we have taken infinite duration sequence and when we will take an infinite duration sequence. Theories, concepts regarding that. Okay, so let us start with the comparison between circular convolution and linear convolution. So in case of linear convolution, then the length of the input sequence can be different. Let us suppose you are having two sequences x1n and x2n, and if the length of both the sequences will be different, then you can choose linear convolution. There is no issue. But in the case of circular convolution, it is mandatory that the length of both the sequences must be equal. Second thing, zero padding is not required. So zero padding is a technique by which we can extend the length of a given sequence. Okay. So when there is no issue regarding length of both the sequences, so there is no zero padding required here. But in this case, if the length of input sequences are different, let's say one length is 3 and another sequence length is, let's say, 5. So we have to make it 5. So whatever sequence whosoever sequence is less, we will add 2 zeros. So the length will become 5 of both the sequences. The input sequence need not to be periodic. So there is no need to be periodic, but here in this case there is a condition that at least one of the sequence must be periodic or extended. Output sequence that we will obtain here is non-periodic, but in case of circular convolution, the output sequence need to be periodic, and this periodicity is the same as that of the input sequence, and the length of the output sequence will be greater than the length of the input sequence, and here the length of the output sequence is same as of both the input sequences. Means like sequences, though two sequences are L1 and L2. So here in this case, the length of the convert sequence, let's say L3, will become L1 plus L2 minus 1, and here in this case the length of L3 will be equal to L1 is equal to L2. Okay. So these are basically the differences between linear and circular convolution. And in case of if you will see in case of DFT, we will see the DFT, then in that case the property is circular convolution. So generally here whenever we have to solve the linear convolution, we will solve that linear convolution with the help of circular convolution, because this particular topic we are studying under DFT. Okay. So here are basically the three methods by which we can convolve two sequence. First one is graphical method, it is also called circle method. Second one method is matrix multiplication method, and third method is DFT-IDFT method. It is also called Stochamp's method, and another method or another name of this method is concentric circle method. Concentric circle method. In some books you will find like it is like this. Okay, concentric circle method. Okay. So now we will see which method is appropriate in what sense. So if you will see the graphical method, in terms of, if we will talk about complexity, it is of moderate type. Matrix multiplication method, this method is most complex method because we have to deal with matrices. And if we will talk about the complexity, then this method is the simplest one, because you know, in DFT-IDFT method we have to take a simple approach. We are having two sequences, we will take the DFT of both the sequences, we will multiply them in frequency domain, and then we will take the IDFT to find out the circular convolution in time domain. Okay. So this is the, you can say, method. So this is most complex, moderate complex, less complex. Okay. So this is I am talking about the complexity, and this complexity is measured in terms of machine, not in human, because when you will deal with pen and paper with this type of methods, then you will find that this is the easiest method. and this is the most difficult method. Okay, so let us start with that. Okay, so I am taking a problem. I am solving this problem using graphical method. Okay, so compute circular periodic convolution of two sequences x1n and x2n using graphical method or circle method or concentric circle method. So this is basically the definition of circular convolution. According to this definition, what we have to take, we will take first sequence, we will take another sequence. How we will do the convolution? We will do the convolution, we will take first sequence, we will take second, we are having two sequences, we will take first sequence as it is, we will take second sequence, we will take the mirror image of second sequence, then we will shift it, then we will multiply it with first sequence, then we will add it up. So that this is basically the process in convolution. Okay, one extra thing you can say x1n and x2m minus n, mod n. Extra thing is this mod n. Mod n means simply it is telling you about the value of n. Let's say n value is 12. So if you are writing here m minus n mod 11, let's say, so you will know the position because it is periodic in nature. So mod 11 means it will start from here, here, here and stop it here. Okay, this is the meaning. Mod 5 means 1, 2, 3, 4, 5. This is, so this is basically mod meaning. Okay, so here you can say the length of n is 4, so that's why we are using mod 4. Okay, and you can see this x2 minus n mod 4 means x2 n minus n plus 4, yani it means x2 4 minus n. Now you can check x2 minus 0 mod 4, yani x2 4 will become x2 0, x2 minus 1 mod 4, it means x2 3. Here you can see x2 0, x2 1, x2 3, x2 0, x2 1, x2 2, x2 3, x2 4. So x2 4 is nothing but x2 0. So this relationship, because basically we are finding through this mod. x2 minus 2 mod 4 means x2 2. Okay, yeah, it means whatever the value of x2 minus 2 will become the same of x2 2. x2 minus 3 will become x2 1. Okay, so these values are required. So what we will do, we are having for length of sequence 4, so we will draw a circle, we will write x1n in between, and we are having 4 sequences. We will take anti-clockwise. You know, anti-clockwise direction is the positive direction, or basically, okay, or corresponding to right shifting when we are taking the case of linear one. Okay, so basically you are moving from here to here, here to here, here to here, like this. Okay. So you can see the first sequence value is 1, then 2 and then 2, and the second sequence, which is x2n, the values are 1, 2, 3 and 4. Okay, now you have to take the mirror image of this. So we have to find out x2 minus n mod 4. So according to this x2 minus n mod 4, what is the value of x2 minus 0? x2 minus 0 will become x2 0. So the same value will come over here. Now we will see x2 3. So we will see x2 minus 1. So x2 minus 1, from here you can say this value is x2 3. That's why we have written x2 3 over here. And also the value of x2 3 comes over here. Then next value is x2 minus 2 is similar to x2 2. So this value same here, and the value of x2 minus 3 will become x2 1. So you can say we are writing it x2 1. Now what we have to do? We have to simply multiply x1n with this corresponding values. So here is the multiplication, you can see x1n into x2 minus n mod 4. So you can see the coefficient value 1 into 1, 1, 1 into 4, 4, 2 into 3, 6, 2 into 2, 4. Now we will add up all these 4 sequences. So the value will become 15. So this is the first value. So let's say we are having sequence x3m. So we have obtained the value of x3 0. So the value of x3 0 will become 15. Okay. Now move to the another second time. What happened second time? Now we will shift it. Okay, shift it anti-clockwise direction. So when we will shift it by anti-clockwise direction, this will become x2 minus n minus 1 mod 4. Okay, so this is like, okay, so x2 1 minus n mod 4. So it means this value, how we are obtaining? We are simply shifting this sequence here, this sequence here, this sequence here. So you can say 2 will become here. So you can see 2 will become here. Okay, so this sequence we have obtained. Now we will multiply this sequence with this sequence, means x1 n into x2 1 minus n mod 4. So when you will do with this, you are having this value 2186. Again you will add up these product, so you are getting the value 17. So this is the value of nothing but x3 1 equals to 17. Then again for m equals to 2, you will shift another, you will take another shift. So this sequence will become here, this will become here, this will become here, this will become here. So you are getting this. Again you will multiply this sequence with this first sequence, you will add it up and you are getting the third sequence. So x32 will become 15. Okay, and then let's again move. Next time when we will move, we are having these coefficient values. Again we will multiply with the x1n, we are having these sequence values and this. So final output that we can see here, the circle convolution 2 sequences 15, 17, 15, 13. So this is about the graphical method. Okay, second method is matrix multiplication method. So in this case we are having two sequences, x1n equals to delta n plus delta n minus 1 minus delta n minus delta n minus 3, and x2n is delta n minus delta n minus 2 plus delta n minus 4. So when you will write the sequence, delta n is defined only at n equals to 0, so you will getting value 1 here. Delta n minus 1, it is defined only at n equals to 1, so you are getting this value 1, minus delta n minus 2 defined only at n equals to 2 and the magnitude is 1, so value is minus 1, and similarly here is value is minus 1, and delta n value 1, and at delta n minus 1 there is no value, so it is 0, at delta n minus 2 magnitude is minus 1, so this value is minus 1. Like this we have made the sequences. These sequences may be given you directly also. Okay, so in matrix multiplication method, this is basically our approach, and I am better is to solve it here, or you can see this basically. So in this case what we are doing, we will take one of the sequences, any sequence you can take. Let's say we are taking first sequence, and with the help of, you can see the length of both these sequences are 5, so there is no requirement of zero padding. First of all we will check is there a requirement of zero padding or not. So here in this case there is no requirement of zero padding. So what we will do, basically we will take, let's say, first sequence, and we are writing first sequence coefficients like this. Sorry, in this case they have taken second sequence. So this is our x2n sequence. So with the help of second sequence we have made a matrix like 1 0 minus 1 0 minus 1 1 0 minus 1 0 1. Okay, so this okay, I think this sequence is 1 plus 1. Okay, then we will, then what happened, this value will become here, 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 and then this will become like this. Okay, so that's why the sequence length is 5. So we have made a matrix which is of coefficient 5 cross 5, and we will multiply it with another sequence. Another sequence is 1 1 minus 1 minus 1 0. Okay, so 1 1 minus 1 minus 1 0. This sequence we have taken, and we will simply do the matrix multiplication here. So after matrix multiplication we have 3 0 minus 3 minus 2 2. So we are having these values obtained. So this is basically the result. So this is method is quite simple when we will solve with copy and pen, if the value of n is not very high. Okay, and last method is DFT IDFT method or Stochamp's method also. So in this case we have given again two sequences, 1 1 2 2 and 1 2 3 4. So what we will do, we will apply DFT. Okay, okay, So this is for the final result. They have shown that x3k will become x1k and x2k, where x1k is basically the DFT of x1n and x2k is basically the DFT of x2n, and x3k is their product, and x3n basically the time domain convolution of this. Okay. So we will let us start with 1 1 2 2, which is our given sequence, and you know the DFT formula, xk equals to xn e to the power minus j 2 pi nk by n, where k equals to 0 to n minus 1. Similarly, the value of n is 0 to n minus 1 here, as we are finding it for sequence 1. So we are writing x1k, okay, and we will solve it. We will simply put the value of n. First we will put the value of k. Let's say x10 we will find, and the value of n, for each value of k, the value of n is varying from 0 to n minus 1, and the value of n is 4 here. Okay. So for n equals to 4, you can see this is the value of x10, this is x11, okay. You will put k equals to 0. So after putting k equals to 0, you are having this equation, and when you will move it from 0 to 3, so what happened? What value you will get? You will get x10 plus x11 plus x12 plus x13. So what is the value in this case? What is the value? Okay, so this is basically the value. Okay, then k equals to 1. When you will solve it, it will become minus 1 plus j. When k equals to 2, it will become minus 2, and when k equals to 3, it is become minus 2 minus 2j. So this is how you have obtained the value of x1k and x2k. Sorry, these are the values of x11, x12 and x11. Okay, sorry, this is x13. Okay, so this 6 minus 1 plus j, 0 minus 1 minus j, these are the values. Now move to second sequence. Again we will apply the same algorithm here, same formula here, same calculation here. So we are having values 10 minus 2 plus j2 minus 2 and minus 2 minus 2j. So now you can see you are having two values, x1k, this, x2k, this. Now you will find x3k. So x3k will be x1k into x2k. So what it means is, it means when x3k equals to x1k into x2k, so what we have to simply check, when you will put k equals to 0, so x30 will become x10 into x20. So you have to find out the value of x10. You have already find it. You have find it 6, and what is the value of x20? It is 10. So the first value will become 6 into 10, that will become 60. So that's why you can see here the value of it is 60. So that's why you will multiply another value if you want to calculate like x31. So x31 is simply x11 into x21. Okay, so this is the value of x3k that we have obtained. Now we have to take IDFT of this value to find the value, to find the sequence x3n. So x3n will become IDFT of x3k, and you know the formula 1 upon n, k equals to 0 to n minus 1, xk into e to the power j 2 pi nk by n, and here we are varying n from 0, 1 to 3. The first value that we will see, that will become from x30, and we are varying for each value of n, we are varying k from 0 to 3. So that's why we are having these values 15, 17, 15, 13. So this is the final answer, or the convolution of two sequences which we have solved using DFT IDFT method. If you want to calculation faster, then you can do one thing. You can calculate these values using matrix method of DFT. Okay, so you know that is not, I am not including it over here. Otherwise there is a method in DFT by which in matrix method you can solve easily these values, so that computation time will become less. Now next is linear convolution using circular convolution. So it is to be noted that the resulting sequence obtained by both linear convolution and circular convolution have different values and length. So linear convolution result in a periodic sequence with a length of 2n minus 1, whereas circular convolution results in a periodic sequence with a length of n. Circular convolution will produce the same sequence values as those produced by linear convolution if zeros are paired at the end of the two given sequences x1n and x2n. So after zero padding, similar methods, graphical matrix and DFT, IDFT method can be used to obtain linear convolution as was used for circular convolution. So simple thing is that we have solved it here using matrix method. So we have given two sequences, we have to make the linear convolution. You know the length of the linear convolution will become, here length 1 L1 equals to 3, L2 equals to 2. So what is the length of convolved sequence? 3 plus 2 minus 1, that will become 4. So what this linear convolution with the help of circular convolution method says that make both the sequences length 4. Make both the sequences length 4 by zero padding. So here the sequence will become, new sequence will become 1 2 4 0 and this sequence will become 1 2 0 0. And now you can apply any method, graphical matrix or DFT IDFT method to find out the circular convolution between these two sequences. And the important thing is that the circular convolution value that we obtained between these two sequences is nothing but the linear convolution of these two old sequences. So I am saying that this is the new sequence and this is the old sequences. So we will perform circular convolution between new sequences, but that will give us the value of linear convolution of old sequences. Okay, so I just want to tell you the method, so that's why I am presenting it here using matrix method. Okay, so simply you have taken second sequence. You have taken second sequence for making matrix multiplication, so 1 2 0 0, then you have made this matrix 4 cross 4, another is this 1 2 4 0, this is 4 cross 1, so finally you are having value 1 4 8 8, and this is the basically this is nothing but the linear convolution of these two sequences 1 2 4 and 1 2, and you can easily verify it also by verification method. You know xn hn, let's say you have taken xn is, let's say 1 2 given here and it is 1 2 4, so you will make a matrix like this 2 4 8, simply multiplying corresponding elements, then so value is 1 4, we will add it up the cross values 8 8, so the same value that we are getting over here. Okay, now filtering of long sequences. Okay, so what happened in some cases, what happened that here in the previous case we can see both these sequences are of finite duration, but what happened, there is a situation where one of the sequences of infinite duration, like you can say you are having a linear filter and input is coming continuously over it, we are it means the length of the sequence either very long or we don't know the length of the sequence. Okay, so this topic can be called like filtering of long data sequence or sectioned convolution. So in this particular method there are two types of method, one is basically overlap save method and overlap add method. So in both the cases what we have to do, we will take the input sequence and we will break the input sequence, we will break the incoming input sequence and convolve it with the filter, convolve it with the impulse response of the filter and find the result, and then ultimately all the outputs that we are obtaining from these segments we will add it up. So I am taking just numerical for it, so we are using it solving using overlap save method. Okay, so this is your sequence, this is the long sequence, overlap save means you have to use this method only, and hn is given to you. Now you are assuming L equals to 5, L equals to 5 simply says that you are taking 5 sequence of this long sequence at a time as a segment, and m is the length of the impulse response you have taken, which is equal to 4, and n is the length of linear convolution of these two sequences, it will become L plus m minus 1, you know it will become 8. So what happened, the sequence will become length 8. So now we are making subsequences. How we are making subsequences? First of all, for first sequence because of aliasing effects and other, we will take n minus 1 number of zeros add before these 5 sequences. So you can say, so here we can say we have added 3 zeros, then 3 9 1 2 3 is this. So this is the first subsequence. Second subsequence, what we will do, we will repeat these two values again, because these three values are overlapped. Okay, then we will take another 5 values, then again we will take this 6 3 4 and we will take next 5 values, and this process is continued until we are having all the sequences. Okay, like here 7 8 9 8 7 5 0 0. So here 5 0 0 is there. So so after it we have to take 5 this again, because this 5 is overlapped. So that's why the last sequence is this. So these are our subsequential, and now our m hn length. So for circular we are finding linear convolution with the help of circular convolution. So we will make the length of this impulse response also become 8. So this hn we will make it 8. How we will make it 8? We will simply add 4 zeros. So your hn will become 1 2 1 1 0 0 0 0. Now you will do the circular convolution between these sequences, means x1n hn will give you y1n here. So y1n is this. This you can solve using matrix multiplication method, which I have already told you earlier. So y1n is x1n in convolution hn, y2n is x2n convolution hn. These are all circular convolution values. Okay, these are all circular convolution values. So after getting all these values, now how we will combine these output? Okay, so we will combine these output like we will remove first 3 values of sequence output y1n, we will take last 5 values 15 22 16 17, sorry 3 15 22 16 17. Then we will remove these first 3 values. So output is 13 18 23 24 21. Then again 22 23 28 33, then again 41 40 36 25 12, and last value is only 5. And how these zeros are due to zero padding, and it will not be the part of the final answer. You can also check it by L plus m minus 1 directly from the sequence to find that whether these zeros will be applicable here or not. Okay. So this is the overlap save method, and similarly in overlap add method there is quite different. You can say the difference is like how we are making the subsequences and how we are basically combining the outputs. So here again we are assuming the length of the sequence, let us say 5, we are taking 5 sequences at a time, length of impulse response is 4. So n will become 8, which is the value of linear convolution of these 2 sequences. So what we will do, we will take 3 zeros, n minus 1 zeros, to make the sequence length 8. So here in this case we will take first 5 sequences, then add 3 zeros, then we will take another 5 sequence, then again 0, then we will again 5 sequences, then again add 3 zeros, and we will again 5 sequences and again. So that's why we have made these 4 subsequences. Now again what we will do, we will convolve this x1n with hn. Hn is again of length 8, 1 2 1 1, then 4 zeros, and y1n is equal to x1n convolution hn. When you will do, so what happened, you will get this value. Okay, this again you can perform using matrix method. Okay, this you again apply using matrix method. So x1n, y1n, y2n, y3n, y4n, all these values we can calculate. But what about the final sequence, which is the combination of all these? So what we will do here in this case, previously the overlap sequence are basically removed, but here we will add up the overlap sequences. Like here you can say the here in this sequence last 3 values are 9, 5 and 3. So 9 will be added with 4, 5 will be added with 13, 3 will be added with 20. So these 3 sequences will become 13, 18, 23. Similarly here 17 plus 5 is 22, 7 plus 16 is 23, 4 plus 24 is 28, and similarly 33 plus 8 is 41, 17 plus 23 is 40, and 9 plus 27 is 36. So now with the So these values basically are replaced by these values. So you can say output will become 3, 15, 22, 16, 17, then 13, 18, 23, then 4, 13, 20, 24, 13, 18, 23, then 24, 21, 17, 7, 4, okay, and 24, 21, sorry, and this will again add up. So 22, 23, 28, then again 33, 38, and again add values 41, 40, 36, and remaining 25, 12, and 5. Okay, so you can say, see the result in both the cases will become same, although the method is different. These are the references that I have taken for the preparation of this lecture. Thank you so much.